So we're going to start with some review about trigonometry, some basically some vocabulary that we're going to be using, and that you need to know them. So when I say an angle of blank is an angle that falls from the horizontal, it's an angle that falls from the horizontal, also known as the angle of declination. So if you're looking at the picture, which angle is described right here? So it's an angle that falls from the horizontal. Is this angle that falls from the horizontal, or is this angle that's falling from the horizontal?
The first one.
The first one, that's right. So this angle right here is the angle that's falling from the horizontal. So this is your horizontal line. I missed the T. So this is your horizontal line. And if I have a line that's drawn, right? The one that's falling from the horizontal is, we call it the angle of depression. So you have to be careful when the question says angle of depression. That means it's the angle that forms from the horizontal down. The other description is an angle of blank rises from the horizontal. Right? So the other one, which is the angle of elevation, is the one that's rising. Rising means going up from the horizontal, so measured up from the horizontal. It's also called the angle of inclination. Theta is a letter, it's a Greek letter that represents a missing angle. Okay? So instead of using the letter X or instead of using the letter Y or whatever, they decide to use a Greek letter because mathematicians like Greek letters. Okay? A lot of the mathematicians were Greek actually. Okay? So theta is one, so if you see that symbol, it represents the letter, the Greek letter, theta. Okay? You can use any letter you want. It's not mandatory to use theta, but at least if you see it, you would recognize it, right?
What is spelling?
Theta, Theta. What do we call the triangle that has a 90-degree angle? Right angle, that's right. So a right triangle has one 90-degree angle. Any triangle that is not a right triangle is called, do you guys know what the name of it is? So if it's not right angle triangle, then it's a straight, it's a triangle. So we call it an obtuse. Sorry, oblique. Obtuse is a measurement. So it's an oblique triangle. Okay? So if it's not right angle, it's an oblique. Okay? You guys remember what the word acute means? What's acute?
I think less than 45 degrees.
Not 45. Less than
90.
9. Right? So if you have a triangle with 3 acute angles, we call it an acute triangle. Okay? So acute means less than 9. Well, we're not right. And then if you have a triangle with one obtuse angle, we call it an obtuse triangle. What's the word obtuse mean?
More than 90.
More than 90. So if you have something that looks like this, that's an acute triangle, right? But if you have something that looks like this, that's an obtuse triangle, right? Because this angle right here is an obtuse angle, right? While all of these angles are less than 90. Are we okay with this so far?
Obtuse means more than 19.
That's right, more than 90. We're gonna define them right here. So right angle means it's equal to acute angle is, we said, less than 90. Obtuse angle, we said it's greater than 90. So these terminologies you guys need to know. What's the sum of the angles inside of a triangle? 180. Can you have more than one obtuse angle in a triangle? Can you have more than one obtuse angle? No. Okay? In a triangle, you can only have one obtuse angle.
That's 419.
Sorry? Only one angle that's more than 90. What kind of triangle is this? The one I just drew.
Right.
Right triangle, right? It's right triangle because it has a right angle, which is a 90 degree. Are we okay with this? Now, if you're looking at this triangle, there's 3 sides, correct? Can you tell me which side is the one that's opposite to your 90 degree? C, right? Do you know what's the name for that side? There is a specific name, special name for it. Do you know what it is? Hypotenuse, that's right. So the hypotenuse, it doesn't change where it's located. It's always across from the 90 degree, okay? So the hypotenuse is always across from your 90 degree, and it's the longest side of your right angle triangle. Are we okay with this? Do we understand that? So the hypotenuse is the longest side in a right triangle across from the right angle. So you locate your right angle first, then you can find your hypotenuse right away. Can I have a hypotenuse in an oblique triangle? Do I have a hypotenuse in an oblique triangle? What's an oblique?
It's any triangle that's not a right triangle.
That's any triangle that's not a right angle triangle. So do I have a hypotenuse in a regular triangle? No. Hypotenuse is only in right triangles. Okay? So you only have a hypotenuse, you only call a hypotenuse because it's across from the 90 degree. Is that clear? I don't want to see you guys calling hypotenuse for the other triangle. Now, let's say this is our angle of focus. So when I say angle of focus, I'm talking about an angle either given to me or an angle I'm looking for. Okay? So let's say this is my angle of focus right here. I'm going to call it theta. Which side is opposite to the angle theta? A, B, or C? A. A is the opposite side of angle theta. Do you guys agree with that? Yes. Okay. So we call it the opposite side. So the side labeled opposite is across from, excuse me, is across from the angle of focus in a right triangle. Now the other side, which is side B, that's the only one I have left that I did not name, right? This one is hypotenuse, this one is the opposite, then I have one more left. That side is called the adjacent side. So it's attached to the angle of focus. And then the angle of focus is the angle given or the angle to be found in the right hand. Now, I gave you another triangle. This is your angle of focus. Name the sides for me. Which one is opposite, which one is adjacent, which one is the hypotenuse? Which one is the easiest one to start with? Hypotenuse, which is what?
C.
Good.
Opposite side B.
Opposite is the side B, is that, do you guys agree with that? So this is my angle of focus, opposite to that is side B. Good. And the one that's left is the adjacent. Okay, so it depends on which one is your angle of focus, that your adjacent and opposite will switch. You see that? So the adjacent and the opposite will switch depending on which one is my angle of focus. Now, when we're labeling a triangle, we always label the angles with capital letters. And then we label the sides with the small letters. Okay? So if I'm going to label this triangle right here, so I'm going to make a triangle. Right? I always label them with A, B, C, right? It doesn't matter which order as long as they're labeled. Okay? Now when I label the sides, side A is going to be across from angle A. So this is angle A, side A is going to be across from it. So I write side A with small letters. Okay? Where is side B? Right here. And side C is. Okay, so depending on, you can call them X, Y, and Z if you want. Okay, now this would be side X, this would be side Z, this would be side Y. Okay, whatever you want to call them, you can call them, but then the side opposite to it that would give it the same letter, but instead of capital, it will be small letters. We're okay with that? So So this is naming the triangles. So when you're looking at any triangle, it doesn't have to be right angle triangle. So if I'm looking at this triangle right here, this one right here, okay, I'm gonna call it X, Y, and Z. Okay? Which angle is the greatest angle? Which one is the biggest angle?
The hypotenuse.
No. Listen. Which one is the greatest angle? X. Remember there's no hypotenuse here because there's no 90 degree. Hypotenuse you only have a hypotenuse with a 90 degree angle. Okay? So looking at this one, it's an obtuse triangle. The biggest angle is angle X. Do you guys agree with that? Are you guys awake? Yes.
I am not.
I can tell. Angle X is the greatest angle, right? Which one is the biggest side that you see right there? Side X, right? So this side X is the biggest side. So always the greatest angle has the greatest side across from it. And the smallest angle is going to have the smallest side across from it. Okay? When the question is asking you to solve a triangle, it means it wants you to find every single angle and every single side. Okay? The question will be solve, and you're going to have to find everything in that triangle. Angles and sides. Is that clear? You're going to take out your calculators and then you're going to make sure that your calculators are in degree mode. It does have to say on the top D or DG or nothing, usually. If it says R or RAD, then there is something not right in the calculator. So make sure it's on DG mode. Okay. Now, check your calculators and find sine, cosine, and tan on your calculator. Can you find it? If you guys are using your phone's calculator, please try to find a better one. Try to find a better calculator than this. Download one, something, I don't know. I don't know, actually, okay. Now, did you locate the sine, cosine, and tan? Okay. Now, if you press Shift for a second, and then you should be able to find sine to the power of -1. So if you press second or Shift, you should be able to see sine to the power of -1. Yeah, you can use them. Okay? We all see that? The sine inverse, cos inverse, and tan inverse. So these are the ones that you're going to be using when you're finding the angles. Okay? So whenever you're finding the angles, you're going to have to use sine inverse, cos inverse, and tan inverse. Now, rounding, and this is very important, so can you pay attention here, please? Sides have to be rounded to 1 decimal place, so 1 point after the decimal. Angles, always to the whole number, so angle should not be 25.5, it's 26 degrees. Okay? Sides, you can have it to 1 decimal. Angle should be to the nearest degree. Trig ratios, which we're going to talk about, it's going to be to 4 decimal place. Okay? So on the calculator, do sine 50 for me. Sine 50. No, I didn't say sine 50, I said sine. Yeah, 50. Put 50. What do you get? You didn't get, no, just sine 50. Sine 50. What do you get?
0.76.
Good. So if you do sine 50, you're going to get 0.76. Keep going.
6, 0. 1 more 6.
So 1 more 6.
0.
0.
Triple 4.
Okay. So there's a 4, right?
Yeah.
Okay. When you get these answers, we call these the trig ratios. You're gonna leave it to 4 decimal place. So basically, you're gonna go 1, 2, 3, 4, and then you're gonna look at this one. This is a 4, so I have to leave the 0 as is. If this was a 7, let's say, then you make this a 1, and then you eliminate this. Okay? So if this was 0.76607, you would write it as 0.7661. And you stop, okay, because you have to round up, okay? So, sides to 1 decimal, angles to the nearest degree, and then the ratios to 4 decimals. Now, primary trig ratios. Make sure you remember this word, or this whatever expression. Because when the question asks you find the primary trig ratios, you need to know what I'm talking about. You don't come and ask me what it is, because I've already explained what it is. So there's 3 primary trig ratios. We have sine, cosine, and tan. You see them on the calculator, correct? Good. So these primary trig ratios, they're used to find side length or angle measures in degree. Does anyone of you know what the primary trig ratios are? So other than when I say sine, cosine, and tan, what do I mean by that? SOHCAHTOA, that's right. So basically, if you're looking at your right, the primary trig ratios can only be used in right angles triangles. That's it. You can't use them in other triangles. So, first thing that you have to do, you have to be able to label your triangle properly. Right? So you have to label your hypotenuse, you have to label your opposite, and you have to label your adjacent properly, depending on your angle of focus. Are we okay with this? So, let's do that. Where is my angle of focus in triangle ABC? A is my angle of focus because that's the one given to me, right? Alright, good. So, where is your opposite, adjacent, and hypotenuse? Where do you start?
The opposite is standing here.
The opposite is?
Baseline.
Okay.
The adjacent is 4 centimeters. Hypotenuse is 5 centimeters.
And why is this the hypotenuse?
Why is it?
Why is 5 the hypotenuse?
Because it's right in the 90.
Because opposite to the 90. Good. Now let's do the same thing to the other triangle. Where is the hypotenuse? the hypotenuse?
Let's see.
1.5.
That's 50.
Sorry.
Okay, so that's the hypotenuse. Where's your adjacent?
12
And the opposite? So, we're gonna find out how they came with the idea of SOHCAHTOA, or how did they figure out SOHCAHTOA, okay? Both of the triangles have a 90-degree angle, which is angle C and angle Z, right? And they both have what? The same what? And they both have the same angle of focus, right? They both have a 37-degree angle of focus. You guys see that? Do they have the same side length? No. Which one is a bigger triangle? X, Y, Z, right? X, Y, Z is a bigger triangle. So let's look at this. So what the first question is asking you, in triangle ABC, they want you to find the opposite over the hypotenuse. So what's the opposite over the hypotenuse? What's the opposite? So 3 divided by, what's the hypotenuse? 5. Can you find me the answer for that? What's 3 divided by 5?
0.6.
Okay. Now in angle XYZ, you're gonna have to find the opposite over the hypotenuse. So what's the opposite and what's the hypotenuse?
It's 9 over 50.
And what's 9 over 50?
0.6.
0.6? Okay. Now they're asking you to find the ratio sine angle A. What's sine A? What's the angle A? What's the measure of angle A?
37.
So that's gonna be sine 37. So on the calculator, you're gonna put sine 37.
0.6.
0.6. Okay. Now, they want you to find an angle ABC. They want you to find the ratio of the adjacent over the hypotenuse.
4 over 5.
4 over 5. And what's 4 over 5?
1, 2.
How about in triangle XYZ? What's the adjacent over the hypotenuse?
12 over 15.
Which is?
20.
Now remind me what angle A is? What's angle A?
37.
So cosine of 37 in the calculator, what does it mean?
27.
0.7 what?
7,986.
So what's after the 7?
9.
So what happens to the 7? 0.8. Right? Because we have to round up. 796 is closer to 0.8.
It was like, if this is a question like outside this, if it's like 0.99.
That would be 1.
1.00.
Mm-hmm.
And it's greater than 7. 5.
Sorry?
When you're rounding up, it's greater than 7.
Greater than 5. 5 or greater. Then you round it up. Okay. In triangle ABC, what's your opposite and what's your adjacent? Opposite is
3 over 4.
3 over 4. What's 3 over 4?
0.79. 7.
How about in triangle XYZ?
9 over 12.
And what's 9 over 12?
0.7.
And let me guess, 1037 is 0.75 as well?
Yeah. 0.8. we round up this?
0.75 what?
3,
We're gonna leave this 0.75. Okay, because we didn't round yet. Now, look at this and tell me if you notice anything at all. What's the same?
The hypotenuse for both A and B, C or
This shows how
same.
we get sine, cosine, and tan.
So let's first focus on one thing. You're right. But let's first focus. Opposite over hypotenuse for both triangles.
Same.
What did I get?
0.6.
For both of them, even though my numbers are bigger, right? So this is 9/15, right? But if I actually do the ratio, these two are going to be the same, right? And then what happened when I did sine of the angle of focus? It ended up being the same, right? So that tells them that the thing is, remember guys, that 37 and 37, both triangles have 37 degrees, okay? So what happens is, they figured out after they did this, that anytime they do that, okay, sine A is always equal to the opposite over the hypotenuse in a right angle triangle. No matter what the size of the triangle is, if you have the same angle, when they do the opposite of the hypotenuse, it's going to be equal to the sine of that angle. How about cosine? What is cosine equal to? Adjacent over hypotenuse, right? Because if you look at the adjacent over the hypotenuse, I got 0.8, 0.8, and then when I did cosine, I got 0.8. How about tan? Opposite over adjacent. So this is where they came up with the acronym SOHCAHTOA, right? So what it means when I say SOHCAHTOA, I mean S represents which line? Sine. Sine equals to what's O?
Opposite.
Over
Hypotenuse.
H is hypotenuse. What's CA?
Cosine.
Cosine equals
Adjacent.
Adjacent over hypotenuse.
TOA means tan equal.
Opposite over adjacent.
So you don't have to think. Okay? So you use the acronym, you know which one to use depending on what you have. Adjacent, opposite, whatever, right?
So we can use this formula instead of putting like 35 cosine calculator.
No, you're gonna, depending on what's given to you. It all depends on what's given to you.
Like I'm asking if there's no calculator, we can use this formula to find the cosine and sine, right?
Depends on what's given to you. Right? What if they didn't give you the side length? You can't. You have to use the calculator to do sine, whatever. But if you're given all of them, yeah, sure. Okay? All right. So, this is exactly what I just said earlier. So SOHCAHTOA is opposite, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Remember, this is only used when you have right angle triangle. So trigonometric ratio can be used to calculate a side of a right triangle if a side and an angle are known. So in order for you to be able to use the trig ratios, right, you can find a side if you know an angle and a side. You must know an angle and a side to be able to find the other side. Otherwise, you can't. So let's look at this example. If I look at the first example, my angle of focus is what? 65. My angle of focus is 65. Which one is the hypotenuse, which one is the adjacent, which one is the opposite? It's already late. Right? Hypotenuse is the x, it's the unknown. The opposite is 15, and I don't know the adjacent, right? And I'm not looking for it, right? It doesn't ask me to find it. Yeah.
What does the first blank say? I can't see. I'm not wearing my
A
contacts.
side,
Oh, okay.
if a side and an angle are known. Okay? So, in this question, in this triangle, I know the opposite. I'm looking for the hypotenuse. Do you agree with me? Okay. So out of SOHCAHTOA, from the SOHCAHTOA, which ratio uses the opposite and the hypotenuse?
So sine.
Sine.
Sine. So that means I know that I have to use sine because I know the opposite. I'm looking for the hypotenuse, right? It makes sense that I use sine. So I can set it up this way. Sine, always sine, cosine, and tan, they come with an angle. They don't come by themselves. So sine what? Sine 65, because that's my angle of focus, is equal to, what's my opposite? 15. And what's the hypotenuse? So it's x. Right? You're looking for it, it's letter x in this case. Could be letter B, could be letter D, I don't know. Right? So I'm just gonna put it as x. How would you solve for that x that's in the denominator? How would you find that x? What do you do?
It should be cross multiplication. It's impossible.
You cross multiply, and then after you cross multiply, what happens? So if I cross multiply here, what do I get? If I cross multiply here, what do I get?
We send one for the as denominator for sine.
Okay.
You cross multiply.
Okay, so what do I get? X sine 65 equals 15. Am I done?
Oh, let's divide both sides by sine 65.
I have to divide both sides by sine 65, right? So x equals 15 over sine 65. Yeah? So, simply, I tell my students, if you're looking for the denominator, look what happened here. So you see that this is sine 65 equals to 15 over x, and this is x equal to 15 over sine 65. So basically this and this, they switch spots. Okay? The proper algebraic method is what we just did. But if you want to do it fast, this is what you do. Just switch spots. So can you guys find me the answer? 15 over sine 65, what do you get?
0.230.
15 divided by that. By sine 65.
16.6.
16.6. what's after that? What's after the 6? 16 point. 666, so that's 16.7. Right?
Yeah, because it's greater than 5.
And what's the unit for that? Centimeter?
That's all you to round up by 1 decimal, 2 decimals.
What did I say earlier about sides to how many decimals? 1. Angles? No decimals, right? Angles should be to the nearest degree. And then the ratios should be to 4 decimals. And I highlighted it for you, right? Where did I highlight it? Previously. Right? So it says here, round sides to 1 decimal, angles to a whole number, and trig ratios to 4 decimal places.
Why didn't I get about the previous page here? This one? You round up the cosine, but you didn't round up the tan.
Well, you rounded the cosine, you gave me the answer rounded, right?
Oh, it was like 0.75. You said it's 0.8. But like 0.76.
I think it was 0.79.
Yeah, something like that.
Yeah.
You rounded it off, right?
Yeah.
But you didn't do the same thing with tan. Like 0.75.
Yeah.
We should write it 0.8.
But then I have to round the other ones too.
Which ones?
When you were looking at the ratios, you rounded these to 1 decimal place, right? Technically, I should have done them to 4 decimal places. But because you rounded these to 1 decimal place, I had to round this the same thing. Because we're looking at this, right? In these cases, you did not round them, you gave me 0.75, right? So I have to leave this to the same decimal place because I'm comparing them. When I want to compare them, I want to compare these to the same decimal place, right? I'm comparing this. I'm comparing this. Right? And this. So I'm comparing these together, and then these together. Right?
So
When I'm
when you
comparing.
divide 4 by 5, you get 0.8.
Okay.
Right?
So because this is to 1 decimal place, I had to leave the others in 1 decimal place.
Okay.
Make sense?
Yeah.
Okay, so what I want you to do right now is I want you to do the next 2 questions.